8 over 3. So we also had to calculate it. Questions on that one? For number 2, were these lines parallel, perpendicular, or neither? They were perpendicular because these slopes are flipped. One is positive, one is negative, so this is perpendicular. And then for number 3, you didn't have to solve this completely, but as you start solving it, if I distribute everything, we get 2x plus 12 equals 6x plus 8. From this, what type of solution would we have? 1. Yeah. If we had the same coefficient on both sides but different constants, there would be no solution. And if everything was the same, there'd be infinitely many. Questions on those 3? There was no solution. These 2 would be the same, but these would be different. So like these would both be 2 and then 12 and 8, or both be 6. One solution would be like this. These would have to be different. Infinitely many of these would all be the same.
So how much does that end?
Those are very thin. So one solution would be x equals some number. No solutions. You'd have 2 numbers that don't equal each other. And infinitely many, you'd have the same number that equals each other, or 0 equals 0. On the back. For number 4, the easiest way to do this is to start at this point, 3, negative 3. And if it's perpendicular to this line, what would the slope of our new line be? Negative 4 over 3. So we could use that slope, go up 4 to the left 3, end up on our y-axis and get our y-intercept. So our equation would be y equals negative 4 over 3x plus 1.
Here's how you get the
up 4 to the left 3. For number 5, we need to solve this first. How would we do that?
Minus maps.
Negative 2y is greater than negative 2x plus 6. And then so y is now greater than, or less than, sorry, x minus 3. So at negative 3, we have a y-intercept. Our slope would be up 1 over 1 as many times as we can. And down 1 to the left 1 as many times as we can. Would this be dashed or solid? Dashed. Mine will just be solid because I don't have space for all that. Shaded above or below?
Below.
Below. So below would be at our y-intercept down here, so everything underneath is dashed. Dashed, dotted, same thing.
Okay.
Right, questions on those 2? Did we have any Dunce Math Khan Academy questions before we continue SOL reviewing? You all are in the library unless it's on your device. But yes. Find, I think you did not this one. Yeah. Find this page in your SOL review packet. I was just about to bring this to you. U, F, G, F, U, 9. This is what he says.
I got it.
Okay. I can say just in case.
I got it. Because they were at the bottom, like the students who did not participate, so we are ready to do it.
Uh-huh. So on this page, vertical lines have undefined slope and our x equals. Horizontal lines have 0 slope and our y equals. So that is something you would need to know. I believe you can graph either or in Desmos. X equals 3, y equals 2. Yeah. So you could graph whatever you think it is into Desmos and see if it matches whatever graph you're given, or if it says graph this, you could put it in and kind of draw it, copy it onto the graph. For numbers 16 through 19, do we need to see any of those in Desmos? Aubrey? 18. Okay. So what we would do is type in these two order pairs. And -3, 1. And you can see that these fall on the same horizontal line. So it has to be a y equals, and you would say your y value is 1 here, so your equation would be y equals 1. On the answer key, if you looked at that, it says 10. That was a typo. Are there questions in that section? Anyone still need this part? For graphing linear equations, part A, type in the equation. Part B, click on the gear. C, choose the table icon. D, plot the points from the table. So that's if you have to actually graph a line. But with those, you could also just start at your y-intercept and do your slope also. So sometimes Desmos has more steps than you just doing it by hand. So you have to figure out which would be better. Do we want to see any of these in Desmos? Javier, did you want to see one? 21. Okay. 21 would be a good one that I would probably use this method for, because then you don't have to solve it to get the slope and y-intercept. Does anyone still need to write this down? Okay, so it'll give you the line. You could find the slope and y-intercept from this. But if you wanted to make sure those points were correct, one, you could click that and count it. Or you could do what they said, which was click the gear. This one didn't have a table because of the way it was put in. Because Desmos is picky, so it'll only let you do the table if it's in slope and intercept form. So I would say with this one, just look for your y-intercept and count your slope from the point given. that would be, you would have to input points instead of it giving you points. So it'd be different. You could do it that way, but it would be different. So put in the expression, look at your y-intercept, find your x-intercept is what it's going to give you and count your slope from there. Now, if this wasn't in standard form, then you'd be able to go into the gear wheel, make a table, and find points from that.
So for the other ones, it would be fine?
Yeah.
So what would that one be? 1/3?
Yeah. 1/3x minus 1. On the next page, this is going into transformations. So these are talking about the different transformations you may see. Changing M changes the steepness. Changing B moves the line up or down along the y-axis. Making M negative reflects the line. All things we've talked about. All of these will be either in y equals mx plus b or in standard form and need to be converted. Yes.
Because my
I was like, you could if you wanted to. Does anyone want to see any of 24 through 29? Aubrey? 21. 24. And Hunter? 25. With these, it's not really you using Desmos, it's something you would have to know. Is anyone still using, or still writing this down? 24 and 25. You're good? Okay. For 24, we're looking at, remember, we're always comparing this to the original. So here, this one has a negative, this one is has a y-intercept of 4. The negative would be a reflect. Let's see exactly how they wrote this. Reflection, reflect, whatever. And then the +4 would be a shift up 4. For 25, now we're multiplying by 1/2, and our y-intercept is -2. What would the 1/2 do? It change this steepness. Is 1/2 steeper or less steep than 1? Less steep. And then what did the -2 do? Down 2. I'm going to say 1/2 less steep, just to be specific. So these will be one of these 3 answers. Reflect, steeper or less steep, shift up, shift down. Any others in that section? On that same page, in this blank spot, A is type the given equation in and point into Desmos. You have all four.
There's one after.
Again, you've got this battery. B is type y equals mx plus b into Desmos and add the m and b slider. C is change the slider. If parallel, change them to be the same slope. If perpendicular, change it to the opposite reciprocal. And instead of moving the slider, you can type in the actual number you want it to be. So if it's parallel and it's 2, we can type in the number 2. If it's perpendicular and it's 2, we can type in -1/2. And then move the B slider until it goes through the given point. Anyone want to see any of these done in Desmos? Did anyone want to see any of these in Desmos?
$30.
30. Anyone still writing this down? Alright, so for this, I'm going to type in the equation for 30, y equals 3x minus 4. And then I'm going to type in the order pair -1, 2. And then I'm going to type in y equals mx plus b. It's going to ask me to add sliders. I'm going to choose all. And then if this is parallel, it needs to be the same slope. So I'm going to change this value to 3. And you could move it to 3 also, but just doing that works. And then I need this to go through that point. So I'm going to just start moving it until it goes through that point. Whole numbers, try to use whole numbers if you can. So my equation would be y equals 3x plus 5. And then you would do the same thing for the perpendicular ones as well. On the next page. Functions, domain and range. A function has no repeating x's and passes the vertical line test. Domain is the set of all your x values. Range is the set of all your y values. In Desmos, one, if it's asking if it's a function or not, it'll be given in a table, a mapping, or a graph. So you have to be able to determine if it's a function or not. For domain and range, it will either be given as a table, a graph, mapping, set of order pairs, that for a function as well. Or it'll tell you if this is your x value, what would your range value be, something like that. But it would give you a function, you could put that in. Otherwise, Desmos doesn't really help you do domain and range or functions, if it's a function or not. For 1 through 5, do we want to go over any of those? Javier? 5. Audrey?
Probably
1 and 5. Okay. Is anyone still writing this down? Okay, so we'll start at 1 and then we'll do 5. For number 1, since this is a set of numbers, we're going to list these out least to greatest. What would your domain be? All the x's, and what would those be? In this case, we do not put repeating numbers, so just -1, 4, 6. For our range, what would that be? Is this a function or is this not a function? Right. Because our x's repeat, this is not a function. For number 5, our domain of this, we're looking left to right. So where does this start? Where does this end? It doesn't end. So this would be everything greater than or equal to -3. And remember that most of these are going to be in set builder notation, not interval notation. Our range, where does this start? Where does this end? It's all real numbers. It does not stop and end. So that would be your y, your e, your r. So let's see. So most of these will be, if it's an all real numbers thing, it'll probably be multiple choice or a choose the correct answer type thing. And then, is this a function or not? No. It doesn't pass the vertical line test. It doesn't have okay.
Do we have in there amount of time?
Yeah, it's unlimited. So you have all day. You may not take that time, but you do have all day.
Number 2.
Number 2. So number 2, you have to look at your graph and find your x values and y values. So least to greatest, what would your x values be? So these are ordered pairs or random points. So we have to list them each out. So -3. And then range, lowest to highest, what would those values be? Is this a function or is this not a function? It is a function. We can do the vertical line test here. Even though we have repeating y's, that doesn't matter as long as we don't have repeating x's. You can go back to that same page so you can write this down. For zeros and intercepts, zeros are the same as x-intercepts. Remember, zeros, solutions, x-intercepts, roots, those are all interchangeable. For these, graph on Desmos and find the intercepts. Now, if it says find the zeros, it's just looking for x-intercepts. But if it says find the intercepts, it's looking for x and y intercepts. Do we want to see 6 through 9, any of 6 through 9 in Desmos?
8.
8, say 8. Okay. Is anyone still writing this down? For 8, we're looking for the intercept, so that means x and y of this function. You can put in the f of x, you don't need it. 2x squared plus 2x minus 12. You may need to move this or zoom out to find your y-intercept depending on the function. So those would be your x-intercepts. And that would be your y-intercept. Now be careful when you are given a quadratic because it'll give you 2 points down here. One is your vertex, your lowest point or your highest point, and the other one would be your y-intercept. So make sure one of your order pairs has a 0 in it. You would just write -3, 0, 2, 0, 0, -12. Okay.
How would we do that algebraically?
You would have to factor it. So take 2 out of everything, and that would be algebra.
It's like trinomial.
Because this is trying to remove here.
So you would get GCF.
GCF first.
X.
This would only help you find your x-intercepts, not your y-intercepts. In order to find your y-intercept, you'd have to put 0 in for all your x's. Or you could just look at this number. That would tell you your y-intercept. So this would be 2 numbers that multiply to be -6, so that would be 1. And as you start doing this, it would be negative, the other way, -2 and +3. So 2 and then x minus 2, x plus 3. But then to actually find your zeros, you have to set both factors equal to 0. And solve them. But if you solve it algebraically, some of these cannot be factored and you'd have to do the quadratic formula. Divide everything by 2 here. On the next page, evaluating. Type the function exactly as you see it. Type F, your number, and the answer will appear. So anytime you need to evaluate, substitute the number in, and it will solve it for you. Would we like to see any of 10 through 13 in Desmos? Okay. 11, I can do that. Anyone still writing this down? For number 11, I would put in the function. I don't think it really matters if you put it f of x or not, but I'll do it just because it's different. Equals minus 4x plus 10. And then f of negative 3. And 31 would be your answer. 31. A7F is all about being able to put these in different formats. So being able to get a table and write a mapping and draw the graph, or vice versa, in any of those ways. Do we want to see 14, any of 14 through 16? Javier, what was your question?
To solve that, did you do the same way we did it as the last problem?
On the group, no. Because this is an evaluating problem, so you put -3 in for all your x's.
Why didn't you find out that was -3
It's always
on this one?
on the problem that's set up. Okay, on the next page. Variation, something we just talked about. For direct, the equation forms y equals kx and k equals y over x. I'm going to read the entire direct and then go on to inverse. For the graph, it must go through the origin, it must be a line. To find a constant of variation from the table, you're going to divide. It says divide backwards, but really you're dividing y by x. And then how to solve for a missing variable, really we're dividing y over x and putting in the value we found. For inverse, our equation forms y equals k over x and k equals x times y. The graph makes the curve on both sides. To find the constant of variation, we multiply. It says multiply forwards, but really you're just multiplying x and y for each thing. To find missing variables, if you find your constant x times y, and then you put that back in, you can solve for whatever. And then the very last thing down here is talking about in word problems. In word problems, y comes first and varies with x, which comes second, always. Now, the way it varies may be different, but that will always be the method. Awesome.
May I ask you that?
Mm-hmm. Do we want to go over any of the questions on variation 1 through 4? And is anyone still writing this down? Okay. We're almost done with this, guys. So you 4. Mm-hmm.
No, I will. So, with that, right, why? Right, I didn't know.
You have to know them. You have to know that this is the format for direct and this is the format for inverse, and this is how you find K. For number 4, the amount of flour varies directly with the number of muffins. So we're going to have direct variation going on. A recipe for 24 blueberry muffins calls for 4 cups of flour. How would I set this up to find K? Which one is Y, which one is X of these two numbers, 24 and 4? 4 is Y, because that's the amount of flour. 24 is X. Sometimes they'll do that and switch them up, so make sure you know which one is what. So this would be K equals 4 over 24. We simplify that, what would it be?
1/6.
1/6. That would be cups of flour per muffin, or 1 cup of flour per 6 muffins. Then we have to find how many muffins can be baked with 6 cups of flour. What are we looking for? X or Y?
Y. X.
X. Because this is Y and this is X. So we're looking for Y. Our K value is 1/6, and we're going to put in, I'm sorry, what I said was backwards. This is X, and we're looking for,
So it's X and Y.
this is X, this is Y. My bad. The number of muffins is X because that's what came second. So we're looking for X, not Y. What you all said was correct, but then when I said it, I flipped it, and I did redo that. How would we solve for X? So with 6 cups of flour, we could make 36 muffins. Me messing up you guys' words probably did not help, but whatever comes first is Y, whatever comes second is X, and use that all the way through.
That's right. We did with Y over X.
You always have to find your K value, and then use that and put that into your direct variation equation.
We didn't.
So this is in the format Y equals KX, but we're solving for X. Okay, on the next page. For best fit, line or curve of best fit, enter your data into a table. Type your regression equation in. For line of best fit, that's y1 tilde, the squiggly line, mx1 plus b. For your curve of best fit, that's y1 tilde ax1 squared plus bx1 plus c. And then the parameters are your A, B, and C, or your M and B number values they give you. Use that to type in your line or curve of best fit equation. And then to make a prediction, you can put that into a table and put X in, or you can type X in your number and zoom out to find the intersection. Number 2. We're going to do number 2, but I will say for number 1, because it's dealing with years, you would need to start that first year at 0 and then ask yourself how many years has it been since. So from 1980 to 1990, that was 10 years, so it would be 0, 10. From 1980 to 2000, that was 20 years, so it would be 0, 10, 20, and then you would keep counting by tens.
So the one, is it supposed to go under it, or is it next to it?
When you type Y and then type 1, it does exactly what it's supposed to. So all you have to do is type in Y1. Anyone still writing this down? Okay.
I got it, go please.
To the bathroom as soon as Kaylee gets back. Yep.
So, in our calculator, now the doctor makes us choose between business and calculator, or we want to.
I do not know the answer to that. I don't believe so.
Have you talked to Jeff?
Not a math class. I proctored English and biology. Fun times. Sure.
Fun.
This is me walking around making
Does
sure.
it really take you that long to read like the whole thing? Like,
I have not read instructions, thankfully, because I know I'm kind. I've been on the back end. I
honestly, you
just
have to read it
wait
for
for
like
people
10 minutes.
to finish, and I like that better.
You have to learn who should be.
I got bored. It gets boring just staring at people take the test. Okay. So 3 or 4, I'm going to plus. So you see that it's a curve. I'm going to type in my curve of best fit equation. Y1. My tilde is in the ABC menu. A x1 squared. So I'm just typing those in order. I type A, I hit X, I hit 1, I hit squared, and it does that format for me. Plus B x1 plus, and then I get this. I would say try to put as many decimals as possible if you get decimals. Because the less decimals you have, the less accurate you could get. The what? To get the one piece. Oh, this. I typed all of this in. So Y1 tilde. I typed in everything.
Wait.
That's not an apple.
Oh.
The ones at the bottom.
So 14.6429 x squared minus 15.926 plus 30.42. So now I have that, and put that in for x. That would be one. Now it's line and check. So you can do this the next part one of two ways. It says when x is 7 after 7 years. So if I say x equals 7, and I find that intersection point, the y value would be my answer. Or you could make this equation a table and put 7 in for x here. Either way, same thing. The line and curve of best fit equations will not be on your formula sheet, so that is something you have to know. $615. What was it asking for? Population.
Nearest whole number.
Nearest whole number. So yeah, 615 rabbits.
How many questions are that spell?
Not that many. Maybe between 40 and 50.
For the math one? Okay, that's for science and history.
Yeah, it's always less than all the others are.
I mean, like, imagine getting 100 questions for that spell.
No, that's ridiculous. Okay, we're gonna do number 1 as well. And then move on to the back.
Honestly, I just got like small.
No. Okay, so number 1's table would start at 0. Then it would be 10, 20, 30, 40, 50. 5, not 6. So this kind of looks like a line. I can put in my line of best fit equation, y1 tilde m x1 plus b it would give me my parameters. So I could put that equation in. Y equals 0.22x plus 4.79. And then I need, if the year is 2025, how many years has it been since 1980 in 2025?
45 years.
So I can put x equals 45 and find that intersection point. So $14.69 would be our answer. Or you could make it equal and put 45 and back.
Yeah, you got it back.
Yes. On the very last page. Yes, you can. With the tiles, you're going to convert the tiles to algebra by counting the tiles and using the key. Remember that positive and negative, if you have one positive x and one negative x, those are going to cancel each other out. Would we like to see any of 1 through 4? Two.
Or 3.
3?
Yeah.
Okay. For algebra tiles, that's something you have to know how to be able to read and then convert. Not something you can really do on Desmos. So for number 3, I would say go biggest to smallest. So what would this be? Positive x squared. And then we have positive and negative x's. So 3 sets of those are going to cancel each other out. So I have x squared minus 2x. And then how many of these do we have? Negative 3. And that would be your answer.
Or x's and the negative x's. When you do it, when you're adding them together, it would become like 1x and 2x instead of just 1.
Do you mean if I'm adding these two together?
I mean, like 2 of the same.
Oh, yeah. So that would be negative 2x or a little positive 2x. Right. Any other ones in that section? Last thing, area is length times width. Perimeter is 2 times the length plus 2 times the width. I believe that is given to you, but I'm not 100%. Yes. So it'll show up on this formula sheet. It'll show you the perimeter and area for a square, a rectangle, how to find the area of a triangle. So that's not something you need to memorize. So, yeah. I've been writing second on all the classes today. I'm just realize that.
Yeah.
See period is the minimum. Do we need to see any of the area perimeter questions? In a moment, everyone's going to find a group of 3. No more than 3. Everyone needs to have at least a group of 3. And I'm going to pass out one of these to your group. This is where you're going to take answers. And then everyone's going to get their own packet. So you're going to get a packet with different sections of different types of problems. Some of them are grouped together, some of them are not, based on objectives. And in your group, you're going to talk about how to solve it, whether using Desmos, algebraically, doesn't matter. You all have to agree on whatever answer you get, and whoever, you guys can trade, whoever wants to write down the answers, whatever, on the paper. And then once you finish a section, I'm going to come up, you're going to raise your hand, your group is going to raise your hand, then I'm going to come check them. If they're all correct, you'll get 2 points. If you miss one, I'm going to start, you're going to go back and fix it, and then you'll only get 1 point if it's correct the second time. And then we're just going to keep doing that as you move through the section. Does anyone have any questions on that? Okay, so I'm going to pass these out first, and then you can get into groups of 3. In your group, no one should be doing all of the work. We're moving ahead. Everyone should be moving at the same speed, same pace. Working on the same problem. We're going to do as many as possible before the end of class. And then what you don't finish, you can take home and use for additional practice. If you have your packet already, you can find your group of 3. Once you have your group of 3, raise your hand so I can bring you your answer sheet.